Building your own house makes a lot of sense. You can become a homeowner for a lot less than buying a home. You can build the house you want. You learn an incredibly valuable skill, one which will allow you to build other homes after this one and allow you to help others to build their homes with the skills you learned here.
People would like to build their own houses, I think, for many reasons. First of all, because they would like to create a home for their families, create a nice environment for themselves to live in, and perhaps they can't find that environment anywhere that exists. There are houses that you could buy, houses that you could renovate, and to create your own environment, but perhaps those don't suit your needs, perhaps they're too expensive, and one would like to build one's own house and start out with a small house and perhaps add to that house as you get more money. It's the biggest investment you'll ever make in your life, and I think that it's important that because it is the biggest investment, it's a long-term investment, and because it's a home that you're going to create for your family, that you need to follow certain processes so that you avoid any pitfalls that might happen, because then if that does occur, it's going to be a very unhappy experience, and an experience where you perhaps would lose money and not be satisfied with the product at the end of the day. So to do that, there are a series of processes that one needs to follow. And the first process is really the buying of the site, or the acquisition of the site, finding the right site. The second would be the planning process and the people that you have to get involved to be able to design and plan your house and get it through council, etc. And then the last aspect is the construction phase, which is probably the most difficult one and where you would be spending the most money. The next thing is to know your budget. If you've already spent a certain amount of money on your site, it's important that you know how much money you've got left to pay for the building of the house, but also all the other professional fees that you may have to pay for. Because the local authority requires that plans are drawn up by professionals, you'll have to pay those people. Similarly, engineers are required to provide structural certificates so that they make sure that the building can stand up, etc. Those things also have to be paid for. So your budget is a very important aspect at this point in time. Other aspects are technology. What building materials are you going to use? One must think about the fact that you're spending money on the house now, but in 10 or 20 years' time you may be spending a lot more money on maintenance. So there are certain materials which you could use now which may cost you more in the beginning, but later on it might save you money in terms of how much money you spend on maintaining the house. Most people unfortunately can't afford quantity surveyors, and quantity surveyors are professionals who work out how much a building will cost. But it's important then, if you can't use those professionals, to speak to builders or other people who know about building materials and find out what the costs of these materials are and what their lifespan is, how long they're going to be around, how much money will it cost to maintain these elements. And then to use these building technologies to create a comfortable environment in your house, which is another important aspect. With our climate, we have a very nice climate around the country, but it differs. The climate in Cape Town is very different to the climate in Joburg or the climate in Natal. So it's important to understand how you orientate your house on the site so that it is cool in summer and warm in winter, and at the same time that you use materials which are appropriate for those environments so that they don't wear and tear badly over a length of time.
From the materials available to us, number one, we can build with blocks, which is a cheaper version, and number two, we can use the clay bricks, which is a little bit more expensive than this brick. But the important thing when building a house is you must build according to what is your budget.
Clay bricks. Clay bricks come in a number of different types and classifications in terms of SABS. Starting with NFP, non-face plaster. They are bricks that come with a minimum average strength of 7 MPa and are used for general purpose in walls that are going to be plastered and painted. NFX, non-face extra, is 14 MPa average, and they are used below DPC, retaining walls, and where you need the strength, for instance, the ground floor of a double-story or three-story building. Face bricks come in a number of different classifications. FBS, face brick standard, FBA, face brick aesthetic, FBX, face brick extra. Most bricks you can only get in one of those. You don't have a choice of all of them. Face brick extra has a very tight specification in terms of color and size uniformity. FBS, face brick standard, has a slightly looser specification where the sizes can vary a bit more than the FBX. You get the FBA, face brick aesthetic. They don't come in a guaranteed size, but the nominal size remains the same. And they are used generally where you need the variation from the norm. It's what you want in your design. Clay face bricks will vary from about 21 MPa up to about 55 or 60 or even more MPa, depending on which brick it is. Again, generally it's applied to that particular brick. You can't order any brick you want in any strength you want. That is how they come.
Now it comes to the building phase. How does one build one's house? We have to, of course, approach somebody who's in the know, someone who has the expertise to be able to do this. There are three different types of people that you can use. The first is a contractor who does this for a living. It's his main job, and he runs larger companies. The second type of person is known as the bucky builder, who does this but on a smaller scale. And then the last person is you yourself as the owner builder. You could subcontract to people and manage the process like that. It's probably the most difficult one, is particularly if you don't have any expertise and no knowledge about building. I don't suggest that that's a route that you follow. But most people would obviously follow the route of the contractor or the bucky builder, as it were. To find that person is probably the most important thing, and to do proper checks, to not only ask for his references, for him to tell you what work he has done and to show you what he has done, but in fact to speak to people that have worked with that builder or with that contractor. Find out what he was like. How did he work? Did he work quickly? Did he work slowly? Did he arrive on time? Did he do things according to the plans? Or did he take chances, etc.? You really need to find out what his track record is to understand how good or bad a builder someone is. But it's important to get the right person to do the job for you.
Accidents are not planned events, but good planning on a construction site can prevent accidents. The first and most important thing for you to remember as a client is that you are responsible for the health and safety of all the workers on site. If you're not employing people directly but employing subcontractors or a contractor to do the work for you, it is important that you make sure that that person abides by all the rules governing occupational health and safety and the construction regulations. The Occupational Health and Safety Act of 1998 has all the relative regulations in the Act. It is important to know that every worker needs to be covered for occupational accidents. In the event of an accident or a death on site, it is important that those people are covered from a financial point of view. This is governed by the COIDA Act, which is the Compensation for Occupational Injuries and Diseases Act, and it's a statutory requirement. One must remember that these laws pertain to South Africa only. It is important that you advise everybody on the site, all the workers on the site, of the relative hazards and the risks related to those hazards on the site. And once you know what the risks and hazards are, you can decide then what type of safety gear needs to be used on that construction site. Most construction sites use or demand the use of hard hats and hard-toed shoes. But one must remember that it's not always practical for someone to wear a hard hat or hard-toed shoes. For instance, if the person is working on a ceiling or doing ceiling skimming, it's impractical for him to wear a hard hat. If the person is working on a roof, which is an area where non-slip shoes are required, it's important that they wear the right shoes. Not all safety shoes are non-slip. Finally, it's important to remember that there are going to be changes in the law, and the changes in the law will be to the detriment of the client, where he needs to take far more responsibility. It's important to remember that safety on a construction site is everybody's responsibility.
The legal aspects are also very important when it comes to building, and the most important one is obviously that you cannot build a building without approved drawings from the local authority. And the second thing is that you'd have to sign a contract with the builder. There are many contracts that are available, the JBCC contracts which are out there that can be used for this purpose, but it's advisable not to ever build a house without signing a contract with a builder, because that builder needs to be reined in, as it were. There needs to be controls as to what he does, and the contract protects not only him but protects you as well in the building process. So signing a contract is an important thing. Everybody needs to have their house registered with the National Home Builders Registration Council, which was a body which was established by the government a few years ago, essentially to protect people who were building their own homes, so that if anything goes wrong during the process of building, then there is recompense for the owner.
Before starting to build, you must make sure you understand the plans of your house, that you have some idea of what the house looks like. The word plan, besides being the word used to describe all drawings of the house, is also the name of a specialized drawing. The drawing shows the house as it will look like from above without a roof on. The plan you pick is a layout of the house and shows the dimension of the walls and where they are to be built. A section shows a cross-section of the house, in other words, as the house will look like from the side if we were to take a big saw cut right through the building from top to bottom. The section indicates how high the doors, windows and walls should be, what happens to the walls under the floor, the size of the foundation, and how the roof should be constructed. The elevation is a drawing of what the side of the house will look like. The house usually has 4 sides, so there are 4 elevations: front, back, and 2 sides. From the elevations, one can get a good idea of what the building will look like.
Now the next phase is the planning and design phase. And it's probably the most important phase of all of them, because this is where things need to be done properly so that at the end of the day you have what you want to have. Something that is effective and suits your needs and that is going to be there in the long term as a good investment for yourself. The first thing really is that you need to plan properly. You need to get hold of the right individuals that can assist you with planning your house. You need to gather all the information that's necessary. You need to find out all those restrictions that are on the site that are written into the title deed. Are you allowed to build a double-story house or a single-story house? How far are you allowed to build from the edges of the property? How high are you allowed to build? Are there any restrictions on materials that you may use, which sometimes happens in complexes, for instance? So all of those aspects need to be taken into account, and it's really advisable to employ a professional person to help you with this. The South African Council for the Architectural Profession has since July last year registered individuals who can assist you with this process, all the way from draftspersons to senior technologists to architects. So there's a variety of people that you can choose from, almost to suit your budget if you cannot necessarily afford the high-end professionals. But I think it's very important that now, these days, plans have to be approved by the local authority, and the people that do those approvals or draw the drawings for those approvals have to be registered professionals. The local authority doesn't accept any plans from anybody who isn't a registered professional. So it's really in your interest to speak to those people right up front and use their expertise to really add value to your property, because that's what you want to do at the end of the day.
On a building site, your 3 best friends are your steel square, a straight line, and your spirit level. They will always tell you the truth. They will keep you from making mistakes. Believe what they tell you and you will do a great job. The builder's square is never wrong. Use it all the time to be sure that the corners you build are exactly right. 90 degrees every time. Never more, never less. The only one who can tell you if a corner is right is your builder's square. Straight lines are everything in a house. There is no in between, no maybe. A line is straight or it's wrong. This way you will start building beautiful walls. Thirdly, to be sure every layer of bricks is exactly level, your spirit level must be with you at all times. It'll tell you straight away if the top of your line of bricks is lying at a slope or level. It will also tell you if the side of the wall is standing perfectly straight up, plumb, or leaning over. This applies to all vertical surfaces, including doors, windows, and walls. All of these must be plumb or your house will be spoiled. So, a steel square, a spirit level, and a straight line. Your 3 best friends until the house is finished. The next thing we must consider is what tools and materials are required in order to build a house. This knowledge is very important, as it will enable us to understand the process of building far better. The first is setting out our tools. These tools are used in setting out your house, and they will comprise of the following. A steel tape. This tape is used to measure off the dimensions of the house. Marking pegs. These can be made out of steel or wood. They are hammered into the ground to mark a point or to gain the thickness of concrete and leveling the foundation. A straight edge. This is the last important tool used in setting out. A straight edge is a length of wood with straight edges, which is used to level off concrete in the foundation, as well as in the floor slab later on. It is also used to measure levels where the distance between 2 points is greater than the length of the spirit level. The next group of tools that we must consider are the bricklaying tools. The first and most important tool is the brick trowel. It is used primarily to spread mortar when bricks and blocks are laid. Line pins and line are used to guide the laying of blocks and bricks. It is important to have a constant line to work to in order to keep the wall you are building level and plumb. Line blocks are used instead of line pins when the corners are built up. They are made of wood or steel and cannot be purchased, and builders normally make their own. And the last tool used in the bricklaying is the gauge rod. It is a long straight edge marked with intervals equal to the thickness of one block or brick plus the thickness of the mortar joint. The gauge rod is used to check if the brick courses are even on different sections of the building. This ensures that all the corners of a particular structure will be of equal height upon completion. The next group of tools used in building are the brick cutting tools. From time to time, it is necessary to cut the bricks or blocks in order to fill in spaces which are smaller than the standard bricks or blocks that you are using. The brick hammer is used for any hammering that needs to be done by the bricklayer, and the chisel side of the hammer is used for cutting bricks or blocks in half. Some skilled bricklayers, however, prefer to use their trowels for these purposes. A bolster is a broad chisel used together with a club hammer for cutting bricks or blocks or cutting chases into brickwork. A chase is a groove cutting into the brickwork where electrical and plumbing pipes are passed. A club hammer is used with most brick cutting tools, such as the bolster, which we have just mentioned, or it is used with cold chisels. Cold chisels are used for chasing walls or pipes, or for cutting holes in brickwork where needed. The fourth group of tools which we will need to consider are the jointing tools. These tools are used to treat the mortar between bricks on those walls that are not plastered, for example with face bricks. Jointing tools comprise of a long jointer, which is used to make the horizontal hollow key joint on face brickwork. The short jointer is used to finish off the short perpendicular or vertical joints on face brick. A pointing trowel is a small trowel that looks like the bricklaying trowel, but it is used for filling in small holes with mortar. And lastly, there is the mastic trowel, which is a long blade that is used for specialized pointing work. The last group of tools are those that are used for carpentry and general building work. There is a wide variety of tools that fall into this category, but for our purposes at this stage, we will confine ourselves to considering only those which are mainly used in the construction of the shell of the house. These include a carpenter saw, which is used to cut timber, and a claw hammer, which consists of a head on one side that is used to knock nails in wood, and a claw on the other side, which is used to pull unwanted nails out again. Once you have all your tools, you'll need your building materials, and one central ingredient that is often forgotten about: water. It all starts with water. This is the lifeblood of your house, and you need to be sure the supply of water does not run out while you are building. On your plot, find the municipal water main and measure a distance 1.5 meters inside the boundary of your plot. That's where you connect the underground stopcock to allow you to control water to your property. Connect the stopcock to the municipal supply, and you have your water supply. Now for the house.
Level sites are obviously the best sites to choose, sites which are closest to the schools and the shops, etc., and those which are out of the wind, get enough sun, or have enough protection from the wind, etc.
In establishing your site, the first thing you must do is to make sure that you take the correct plot allocated to you. Then you must locate your property pegs. If you are in any doubt, please contact your project manager or building inspector. Then you must clean the site of all grass and vegetation. After this, you should erect a site toilet if you do not have proper toilet facilities nearby, and a shed in order to store your building materials. You may even consider building a temporary shelter, which you can stay in while you are building your house, providing the necessary approval is obtained from your local municipality or local authority.
Then the legal requirements for sites are also very important. There's a thing called a title deed restriction, which may exist on your title deed. The title deed being a document which registers your property, describes your property, tells you how big it is, and then most importantly tells you what you may or may not do on that site. And it's important that you get hold of that title deed restriction or title deed document before you've even bought the site. You need to ask the estate agent, what may I do on the site? What am I allowed to do? What am I not allowed to do? Before you go and spend a lot of money on buying that site and then find out later on that you cannot do this or that or the other thing. So the title deed is an important document. It's normally held by the bank if you have a bond on the property, and you will only get the title deed effectively once you have paid off the bond. So in the meantime, you can get hold of the title deed from the bank or from whoever's holding it and find out what the restrictions on the site are. That's the main legal requirement on any site. When it comes to the finances for a site, obviously there's the bond which needs to be considered. How much is that site going to cost? If you're going to build, then you need to work out your budget. You need to really understand how much money can you spend on the property, or how much money can you spend on the building itself. You have to weigh up all of those things one against the other, and then get access to funding, which can normally be done through a bank. But you must remember that the requirements of a bond can be quite strenuous. They will require you to hand over all of your financial statements. They can work out whether you can actually afford to buy the property, and then once that's done, register it in your name. There are other costs which are also involved when you buy a piece of ground, such as transfer costs that you would need to get the property registered in your name. There might be attorney's fees which might need to be paid. There might even be estate agent's fees which need to be paid. Other costs which may have to be paid for are things like services which the site may not have. There may not be electricity connections, there may not be water connections, there may not even be sewage connections on the site, and you would have to pay for those through the local authority.
When you build a house, there are 3 connections that you need to do. Number 1 is your water connection. Number 2 would be your sewer connection. And the 3rd connection would be your electrical. Let us look at certain terminologies used when we are going to build a house. In our case, we are using Mr. Jackson's property. Mr. Jackson is now ready to build his house. He has submitted his building plans. And number 1, Mr. Jackson has an ERV number on his property, which is ERV number 1112. That ERV number will be registered with the council in Mr. Jackson's name. And when we are going to start setting out the building, it is important to locate the pegs, that is steel pegs, that is in the ground. Sometimes it is not visible, then you must go and look for it until you find the 4 located pegs for the property. When the 4 located pegs has been found, a line must be strung, and then we're going to start setting out the profiles. On the profiles is your corners on your house, in conjunction with a plan, so that you can have your example 3 meters from the boundary, 4 meters from that boundary, and follow the house. When we are going to set out the house must be square, right? And when the house is square, obviously the house is ready to be built. We are now going then to start building, setting out the house for the foundation, and the trenches will be dug. The trenches is dug according with the specifications of the plan. It is in dimensions of 700, and the thickness of the concrete must be 1 brick, which is 230 millimeter. Before casting the concrete, Mr. Jackson must make sure that the building inspector come out to inspect the trenches before any concrete can be cast.
Once your site has been prepared, you're ready to set out your house. To do this, you must first study the site plan of your house. The site plan is usually located at the bottom right-hand corner of the house plan to scale of 1 in 200. From the site plan, you can determine the layout of your house relative to your plot. In other words, the distance your house will ultimately be from the boundaries of your plot. Setting out your house's layout, your measurements will need to be exactly right. Each measurement affects the next one, so if you rush any of them, it's going to show up in an incorrect angle somewhere down the line, and you'll have to start again. So take your time to get the right measurements. Once you know how far the front of the house will be from the boundary of your plot, you need to be sure the building line is straight. The house starts here.
Dit is die buitekant van die muur nou. Daai spykie wat daar is. So jy kry jou binnekant is 280 is die muur se dikte. En van jou buitekant af van die muur af gaan jy oor na 230 toe om jou muur in die senter van jou konkriet te kry. En as jy daai dan gaan jy jou 700 wat die wyte is van die konkriet. So jou konkriet gaan 700 by 250 dik wees. En dis die 700, dis jou buitekant van die muur. En daar is my 280 en dis my trench so buite wat die muur op gaan staan op concrete.
To double check the house is square, check that the front corners are right angles. If you don't get a right angle, then adjust the side angle as needed. When digging your foundation trench, keep the following in mind. As you dig, try to keep the sides as plumb as possible. At the bottom of your trench, use a compactor to compact the floor of your trench and to make it as level as possible. Use a spirit level to check this and a steel square to make sure that the sides of the trench are plumb. Your trenches must be inspected, tested for density by the local building inspector before you can commence the laying of your foundations. Once the inspector is happy with the trench, it's time to mark off how high you want the concrete in the trench. 220 millimeters is the right height. To do this, cut pegs at least 300 millimeters long. Mark off 220 millimeters from the top end of each. Then, hammer these pegs into the floor of your foundation trench, right down the middle, and hammer them in up to their 220 millimeter mark. So there is 220 millimeters of every peg left above the floor of the trench. To check this, lay a plank on top of any 2 or more pegs and check the plank is perfectly flat with a spirit level. The top of the pegs is how high you will pour the concrete foundation. Now you're ready to pour. To measure how much sand goes with how much stone, water and cement, use a 25-litre or 5-gallon drum. The amount should be as follows: 5 units of stone with 4 units sand, 1 unit cement and as much water as you need. To mix up the different parts, get yourself a large and strong square board and put it on a level area. The first step is to pour the right amount of sand onto the board, making an opening in the middle into which you then pour the cement. Mix those two very well. Then, make an opening in the middle again and add your stone to the mix. Now as you start mixing sand, cement and stone, keep adding small amounts of water as you mix, and mix until all the stone is evenly spread through the sand and cement, and your concrete looks like lumpy porridge. That's the sign that it's ready to pour. Most important to remember is that you must pour all your foundations in one day. If you don't, then they will set at different times. You will get weak points and fractures that water can get into, and you won't have one continuous and strong base on which to build your house. So make sure you have the time to finish the job in one day. Using your pegs as guides, pour the concrete to the height of the pegs. If you are constructing a double-story building, then usually steel reinforcement is required. Leveling the foundation all round using your straight edge and spirit level will ensure that when you pour the foundation's concrete to the top of the foundation pegs, the concrete will remain level and therefore make the setting out of foundation brick or blockwork much easier. That should be your foundations done. Now you just have to wait 3 whole days for the concrete to set before building can begin. After the 3 days the concrete is taken to dry, the serious building can begin. The foundations must be checked for level. This is done at each of the 4 corners of the structure. Each peg must be long enough to extend above the trench. The next step is to try and transfer the main leveling point, that is the highest ground level, onto the nearest peg, and from that one to the other 3 pegs. This is done by using a dumpy level, or water level from the MLP. Measure off another 200 millimeters, which is the level at which the damp-proof course is to be laid. Using your gauge rod, you are now able to calculate the number of courses you will need in order to build up from the concrete footing to the floor slab. Before laying out your foundation wall, you must have a reference point for height. From the foundation level upwards, mark off block courses on the peg located at the highest ground level from the concrete foundation. Mark these block courses to about 200 mm above ground level. Now mark the position of your wall onto the foundations. Taking your mark from the nails you hammered into the wooden profiles, use string again to set out the line of your walls. That line needs to be marked on the foundation concrete and must be in exactly the right place. So, the way to mark it right is to use a spirit level and at each end of the wall line, mark out a point in the concrete. Draw a chalk line between these 2 points and then you have the wall line marked in the foundations. Since you are now ready to build a wall, you'll be needing to mix up the right mixture of mortar. Before doing that, it's a good idea to make a strong mixing board. The mortar is then made up, either with lime or with no lime. With lime, take 6 parts of sand, 1 lime and 1 cement. Mix all these together first before adding the water. When you do add water, 5 to 20 liters should do the job. Add a little at a time. Without lime, you still use 6 parts sand, 1 cement and 15 to 20 liters of water. Next, mark off from the footings the dimensions and positions of the first course of blocks. This is done by using a sharp metal instrument and your folding ruler, or straight edge. The purpose of doing this is to create a guide for the laying of your first course of blocks or bricks. You must not forget to allow 10 mm between each block for the mortar. The foundation walls consist of 2 separate single brick or block walls, or leaves as they are more correctly called, with the cavity between them. When the foundation walls are completed, this cavity is filled with a weak concrete mix to 1 course below floor level. The first blocks or bricks you lay will be on the corner. Place full blocks with no mortar so that they form a corner. The joints separating them should be plus minus 10 mm wide. Mark the position of these joints on the concrete foundation, just outside the wall line. Then remove the blocks and lay a bed of mortar for 3 blocks. Lay the first corner block and tap into position. Smear the ends of the adjoining blocks and lay according to the markings of the joints. From here, you will build along the wall line and up, using a block course gauge to be sure each level of blocks is in the right place. Laying blocks is easy and reliable if you stick to the right method. If you're not sure, just call the Concrete Manufacturers Association for advice. And remember, block laying courses are available. Building your foundation wall starts with building up the 4 corners first. As you build up each new level, lay your blocks so that the vertical joins on the level below line up right in the middle of the blocks on top of them. This increases the strength of the wall. You must not have 2 layers of blocks with the same vertical joint line running through. Also, check as often as you can that the blocks are level as you lay them, and that the wall is plumb straight. Checking both of these all the time is critical, because adjusting the wall later when you detect a problem is very difficult and a waste of your time and money. As you build level for level, fill the blocks with mortar as you approach slab level. By the time you reach the top of the foundation wall, all your checking of every course or level of blocks should result in a level wall, 1 block above the ground or 200 mm above ground. The number of courses that gets you to this height may be the same all round if your foundation wall was the same depth, but it may be different if you have built up from different depths or steps in your foundation. At the corner where the natural ground level is highest is where you take your reference for the top of the foundation wall. 200 mm above this natural ground level is the top of the foundation wall and will then be the floor level inside your house. Now you fill the gaps inside and outside your foundation wall. This is called the filling well, and you can fill it with the soil you dug up for the foundations. This soil needs to be watered and compacted as you fill. Watering settles the soil. Then it must be compacted as you fill, and the best way is to fill in about 200 mm, then compact that whole layer of filler, and do the same again and again in 200 mm compacted layers, inside and outside the foundation wall. Inside the wall, the filling well must reach a level 120 mm below the top of the blockwork. This allows for a 20 mm layer of sifted sand and a 100 mm slab of concrete, which will soon form the floor of your house and come up to the level of the top of your blockwork. Once you've compacted and leveled the inside of the wall lines, you will lay down a 20mm layer of sifted sand, compact it and water as you compact it to get it to settle. You must be sure that it is free of any sharp and foreign matter, particularly in lower laying areas where water penetration is common, and therefore the use of a plastic underfloor membrane is necessary. When you have completed compacting the full area, the building inspector must be called in again in order for him to test the compaction density and give his approval. When this is received, you're ready to cast your floor slab. Check that the surface is smooth and free of stones before starting your concrete slab. The first step in throwing a slab is the plastic polythene sheet that goes over the sand and under the concrete. This will give your concrete slab a stable, waterproof basin to settle onto and will allow the slab to dry consistently without any seepage. First, lay the polythene sheet over the sand and then over the blocks of your foundation wall. Tuck the sheet well into the corners of the wall and then secure the sheet over the foundation wall with loose bricks. Because the polythene sheet will not be wide enough to cover the whole space, you need to join two sheets down the middle of your space. Finally, once you know where your electrical conduit pipe will run, plug the ends with pieces of wood, lay the electrical conduit on top of the polythene, and you're ready for the concrete. The process for mixing your floor slab concrete is exactly the same as it was for your foundation concrete. To measure how much sand goes with how much stone, water and cement, use a 25-litre or 5-gallon drum. The amounts should be as follows: 5 units of stone with 4 units sand, 1 unit cement and as much water as you need. The whole slab must be poured in one day, so get enough help and start early. Your first pour should be at the corner furthest away from the mixing place, and from there, work your way to the nearest corner. Once your slab is dry, you can lay down the damp-proof course, or DPC. The DPC is a layer of plastic designed to stop damp rising up through your walls. You start by locating what is left above the slab of the polythene layer you used as a basin to contain your concrete slab. Like the pastry in a baking tray, there will be some hanging over the side of your slab. Fold this polythene flat over the foundation wall and start laying the DPC over the polythene. You will run a layer of DPC over the top of your foundation wall, right around your entire wall line. At the corners, you must lap this DPC over a few times. The walls of your house will now be built on top of this protective damp-proof course.
The advantage of the cavity is the inside of the house will always be warm due to the fact that this course, the water will penetrate and the water will run out by the weep holes, the water will never run into the house, which means the inside of the house will always be dry.
First, carefully mark out the positions of your doors, and after 3 days, once the concrete slab is dried, mark out where your internal walls will be. From here, you're ready to start building up.
It is important to keep the ROK brickwork plus with the face brickwork. As the walls go up, this brickwork will always be the same height as the face. And always clean around, and that is the standard that we will set as we go up with the entire wall.
First, take your block course gauge and mark those block courses onto the door frame, starting at the top and marking both left and right sides of the frame. You can do exactly the same with any window frames you will be using. Setting your door frame in place, support the frame with planks nailed to the head and at the bottom of the boards, with blocks at the foot of each plank to keep it in place. Check that the top or head of your frame is level. If it is not level, then adjust it with wedges under the door frame until the top is level. Also ensure that the frame is plumb and that it is not leaning either to the left or right or leaning forward or backward. Where you have a door and a window that are adjoining, Before you nail the window frame to the door frame, you must be sure to fill the groove with mastic. This will seal the joint. Also, be sure the grooves on the window frame line up right with the grooves on the door frame. Then you can nail them together. Now for your project to start looking like a house. First, you should have a block course gauge in place on each outside corner of your wall lines. Make sure these block course gauges are plumb and kept in place with timber supports. These will ensure that your walls are level and consistent all round. Now, as we did with the foundation walls, start by building up the corners first. Build up 2 courses at a time on each corner, then fill in the walls between. Keep using the course gauges to line up the top of each course. Keep to this routine because it is a method to make sure your walls are always straight. If you don't check and keep checking, there will be problems with your walls. When it comes to your internal walls, you need to put in wire wall ties to give the internal wall stability and hold them to your outside walls. These ties must be included every 400 mm you build up. In other words, with blocks of 200 mm, you put ties between every 2 block courses. Using 3.2 mm thick galvanized wire ties, you bend the ties into a double L shape. The long side will run along the internal wall, the short side along the external wall. Start by running 300 mm of wire along the wall line towards the internal wall joint. Bend this at 90 degrees in the direction that the internal wall runs. When you start building in your door frames, there is a very important detail to get right underneath the door frame. It's all to do with keeping damp out. Before you put your door frame in place, lift the damp-proof course and brush out all the mortar and any sharp pieces lying underneath it. Now, look under the bottom of your door frame, the threshold, and you'll see 2 grooves. As you place your threshold down, you want to wedge the DPC right up into the back groove of the threshold to keep the damp out. To do this, you need a weather bar. A weather bar is a length of galvanized hoop bar which will push the DPC right up into the groove of the threshold and keep it there. When pushing the DPC into the bottom groove of the threshold, be careful that you don't put a hole in this protective plastic, or else damp will rise through it. The area around windows is less secure than the middle of a solid wall, because there is not the structural strength of blocks and mortar on top of other blocks and mortar. This puts the area around windows under greater pressure, and is why this is a place that cracks can develop. Now remember, as you build up, that as you reach 1 block course below where your window frame is, you must build what they call brick force under that layer of blocks which support the window. Brick force is a metal reinforcement in the shape of a grid, which is used between courses to give strength to the wall and prevent cracks in your plaster. You will need a length that runs 600 mm either side of where your window will be. As you build up internal walls, you will be installing metal internal door frames. Some points to be sure of here are: all the hollow blocks right next to the door frame need to be filled with mortar. Remember this for every course you build up. It gives the frame extra strength. Before installing your metal frame, fold the lugs out so you know exactly where they are. These lugs are built into the blockwork around the frame as the blockwork progresses up the frame. They secure the frame in place. As you build up each level and cement the lugs into the blockwork, you will also fill the back of the metal frame with mortar to secure it solidly in place. Bend the door lug down into the block hole and then fill the hole with a mortar core. Before mounting your window frames, do the same as you did with your door frames, and with a block course gauge, starting at the top, measure and mark the block courses onto the window. Again, remember that for structural strength, you must have a layer of brick force beneath the block course that supports your window frame, and it should run 600 mm either side of the window. Mounting your window frame in the right position, make sure that the window head and door head are at exactly the same height. Secure the frame in place from the top by nailing a plank into it, the plank secured from the floor, with a block. Now you can do fine adjustments, ensuring the window frame is plumb. The lintels, which provide extra support for the wall above your windows and doors, need to be installed with real care, for safety and to avoid cracks later on. First, place the lintel on top of the window frame or door frame and check that it is level. If you are putting in a single lintel over the door and window, It will be wider than a meter, and so you must carefully support the center of it with a temporary timber support strut before building anything over it. Also, be sure that your lintel rests on 200mm of brickwork either side. Once you have filled blocks in on either side and you're ready for the next course, you will need to do two things. Fill the lintel with mortar. Once you have a layer of mortar in place, ready for the next blocks, place a layer of brick force running along the top of the lintel and over onto the blocks either side of the lintel. Embedded in this mortar, the brick force will give added structure to this area. Before you start building the next course above your lintels, you need to build in wire roof ties which will secure the roof trusses in place. Each roof tie should be a double strand of 4mm thick galvanized wire in an L shape with the long vertical side of the L 1 meter in height, while the short foot of the L must be 200mm long. Before laying the next course, you must take the number of roof trusses you will have and with a measuring tape mark the position of each truss, as well as the midpoint between each truss. Now you start laying the course above your lintel with the blocks that have roof ties wired into them. To anchor your roof ties, take the ties, wrap the bottom of the L through and around the inside wall of the block hole, and tie the wire well above the central strut of the block. These roof ties wired into your wall will act as anchors for your roof. As you build up the next block course, these wires will pass straight up through the hollow inside of the blocks above, so that at the top of your wall, the wire sticks straight up and out, ready to secure your roof trusses in place. Once you've built up the next course above lintel level, you must build in a complete layer of brick force to give this area stability and strength. Normally, you will build another 2 block courses above this brick force. So above the lintel over your windows and doors, there will be 3 courses, making a distance of 600mm from the top of the lintel to the top of the wall. The wall plates are lengths of timber running along the top of the wall that will be a timber foundation for your roof structure. These wall plates are secured in place by every second wall tie. In other words, there will be a roof tie for each roof truss and also roof ties in between each truss. There are ties that secure the wall plate in position. Setting the timber along the top of the wall, flush with the inside edge of the wall, wrap the wall tie over the wall plate and nail it to the inside face of the wall plate. Again, only use every second wall tie, leaving the rest free to tie the trusses in place. To secure each truss to the timber wall plate on top of the wall, wrap the roof tie tightly over the rafter, twist it, and nail it flush with the inside face of the wall plate. Before positioning the rest of the trusses in place, mark a wooden batten with the correct truss spacing. Once you have 3 trusses in place, you can use this to check spacing is right at the top ridge of your trusses. Once you have positioned and roof tied another truss or 2, you should brace them with battens nailed diagonally across. This bracing is temporary and will be removed later. When you think you have each truss in place, check that it is level along the eave of each truss. Also, check that each truss is not leaning towards or away from its neighbor, by using a level to see that it is plumb. Once your trusses are in place and checked, then nail permanent support braces to the underside of the rafters, starting under the top of the first rafter and using 2 nails per rafter. This strut should run down the wall plate against the 3rd truss along. The bottom end of the strut is nailed to this wall plate with 2 nails. Once you have these struts in place, you can remove the temporary braces on top of the trusses. Once you know where your hot water geyser will be, get 2 supports of 75 by 50mm thick and as long as required, and nail them to the top of the beams. Also, be sure that there is a 200mm overhang of your rafters over the outside edge of your wall. The gable wall is the triangular-shaped part of the wall between the sloping sides of the roof. When building up the gable wall, roof ties which secure the trusses from the side must be built into the brickwork. Trusses are also secured by these wire ties from the sidewall. These ties use a 3.2mm thick galvanized wire secured the same way, by looping and tying it around the center of the hole in the middle of the block. These ties are wrapped around the second truss and tied above it. Purlins are long wooden struts mounted across your trusses to give the roof structural strength. The type of roof covering you choose and the directions from your supplier will tell you how many of these you need and how far apart they should be spaced. To prevent birds nesting in your roof, fill the gap between the top of the wall and the roof sheets with mortar or eaves filler pieces, which will be supplied by the company that makes your roof sheets. Where your rafters meet the top of the wall, you should build the wall up between the rafters with blocks. Roof sheets must have a 70mm overhang to the eaves. Setting out the layout and support battens for concrete tiles is very important. First, mark the position of the plaster batten direct in line with the exterior wall face at both gable ends. Then, mark the position of the ridge batten 25mm from the roof apex at both gable ends and strike a chalk line between the 2 points. Setting out your tiles, you need to start by laying down one course of tiles at the eaves or bottom end of the roof. Make sure there is an equal overhang of 70mm at both ends. Adjust the row of tiles until these overhangs are equal. You will also set out a course at the ridge or top of the roof. Once the courses of tiles at the ridge and eaves are correctly set out, start installing your roof tiles by marking each third tile position on the battens. Then start tiling from left to right and from top to bottom, taking up to 3 rows of tiles up at a time. Once you've set your top row of tiles, you must mix up mortar to the right consistency for bedding and positioning of your ridge tiles, the cap that goes on top of your roof. The right mix for this mortar is 3 parts plaster sand and 1 part cement. First, put a plastic damp course 150mm wide along the entire top of the roof, covering the top course of tiles. Where this damp course ends on either side of the ridge is where you must take a trowel and put mortar onto the top course of tiles. Doing this all along the roof makes a bed which you can press the ridge tiles into. At the bottom of the roof, where your lowest line of tiles hangs over the fascia board, this line of tiles must overhang the fascia board by 50mm. Starting at the bottom eaves of your roof, place the first rake tile against the second course of tiles and nail it into position. Be sure to use non-corrodable nails for these rake tiles. Each new rake tile is laid partly over the top of the one below it, against the side of the next course of tiles nailed into position. The first step in installing your ceiling is to put brandering up. The brandering is a series of timber battens running underneath the roof trusses, which you nail your ceiling into. For unplastered rhino board, over the joints between the rhino board, you will now fix cover strips with the ivory face down and secure them with 38mm galvanized nails at 150mm centers. Next comes the cornice between the top of your wall and the side of the ceiling. Before fixing the cornice in place, apply a Creatstone filling along the wall side of the cornice. Once you have done that, then you can fix the cornice to the brandering through the rhino board ceiling, using 38mm galvanized nails at 350mm centers. Next, you will plaster the entire surface with 6mm of Creatstone plaster, followed by a skim coat of Gladstone or Creatstone to smooth the surface. To allow you to get access to the roof, you need to build in an access panel. It will be 600mm wide by 900mm long. When it comes to installing the electrics in your home, it must be done by a qualified electrician.
Starting with electrical work is doing it in stages. The first stage will obviously be when the builder is building the foundation finish. Before they cast the concrete, they'll have to call out the electrician. He'll have to put in his conduit before they cast any concrete. Then the second stage is the electrician will set off site until they finish building up the walls roof height. When they're building the walls up roof height, they'll have to call out the electrician again to put in his conduits into the wall, his switches, his plugs, his boxes, everything. His main box, DB, outside meter box, everything in. Then, after that stage, the electrician go off site again until they put on the roof. They're calling out the electrician again to come do the tubing finish. That means tubing all the lights in the roof, tubing for cylinder, tubing all the conduits to the DB, tubing to the outside meter box as well. Then, after that, when they finish with the roof, the electrician get off site again. The electrician comes in after they finish plaster. Then the electrician wire all his wiring, all of his plugs, lights, cylinders, stove, everything the wires finished. And after that, electrician sets off site again. Then he waits for the builder to finish the ceilings and give the place a first coat of paint. When they have a first coat of paint on and the ceiling is finished, they call the electrician out again to come fit his lights, his plugs and switches, his DB, and finish off all his work. After that, he'll have to get out the inspector to come and inspect the house so that he can give a compliance certificate so that the house can be signed off. When the house is signed off, that is basically where the electrician is finished and give the clients a compliance certificate. I would advise owner builders to take a qualified electrician because of the safety, and it's a specialized area.
Just like your electricity supply, water supply is a very difficult installation and should be done by a licensed plumber.
What is plumbing? Plumbing work is anything to do with the disconnection, alteration, installation, maintenance and repair of any part compromising a water supply system. That would include the disposal of wastewater and firewater from that system into the main sewer. The type of undertaking that you're required to do might be small enough not to require plans, but if you're not sure, always inquire. Your local authority or municipality is there to help you and to advise you along the way. So, don't forget, make the call and get the best advice possible. Our inspectorate is quite busy and sometimes have not got the time or the resources to always see personally to every single job. But in terms of the law, they have the right to inspect your property based on your plans and your undertaking prior to, during, or on completion of that particular project. On commencement of the plumbing installation, in terms of water services, standardized forms are available from your local authority. These would be for the connection of a water main and the general practice of good plumbing as required by the local municipality. Always ensure that you have a correct sized water main feeding that property. That would also ensure that you have a connection which will allow also for the building process to take place and the water requirements on that site. In order to design a system like this, or for your home, you would probably need the services of a qualified professional, a plumber, a registered plumber, in order to size and correctly evaluate your requirements. South African National Standards is a requirement of installation, the compliancy that in fact we abide by in order to provide a modern home with safe plumbing. Ensure that you are aware and that you are familiar with the SANS 10252. This relates to the installation of pipework and the installation of drainage to a premises. Always ensure that you don't forget to lay your pipework in such a place as where it's accessible. Do not lay your mains inside the slabs or concrete structures of a home. Please ensure that you use a sleeve or that you run these particular water reticulation services on the surface of the building. As ugly as it can be, these things can be maintainable and easily accessible. In terms of water storage systems, and particularly the hot water storage system, these carry their own bylaws. And in terms of the code of practice, SANS 10254, the installation of a geyser like this is critical to your home. Try apply good logic when building your home or when making alterations and upgrade to solar. It's free energy from the sun. Remember, these are dangerous items, and if installed incorrectly, you can have serious consequences. With regards to drainage, always ensure that you have a drainage connection and apply through the municipality or your local authority to get one. This will allow you to plan and strategize the evacuation of waste and solids from your dwelling. Always leave the trenches open and contact the building inspector so that he can inspect your pipework and the general layout of your plumbing. Backfilling of the trenches is an essential part of this job. Make sure that it's done properly in order to avoid costly and timeless delays in redoing it. This will leave you with a maintenance-free, robust and cost-effective system. And make sure it's signed off by your local authority.
In the open drainage system, the bath, basin, sink and toilets drain from the house to a gully, from the gully to an inspection chamber outside the house, from there down a sewer pipe to another inspection chamber a meter from your boundary, where it connects to the council sewer. The gully is the first intersection of all the drainage pipes from the basin, shower, bath and the sink in the house. The inspection chamber is an underground chamber which allows you access to the drainage system. It has an open stoneware channel at the bottom, allowing you to see if the drainage system is working and passing waste, and allowing you access to the sewer pipes to clear them if necessary. The chamber has a concrete floor, which is sloped or benched from the sides of the chamber down to the open stoneware channel running through the middle. The difference between an open and closed drainage system is that the closed system does not have access chambers. Instead, it has a rodding eye in place of each access chamber. If you choose a septic tank drainage system, the system is exactly the same as an open drainage system, from the house into the gully, from the gully into the inspection chamber. Feeding out of the septic tank is a 100mm pipe that runs directly into the soakway. Most important, this soakway must be a minimum 6 meters away from any building and a minimum 100 meters away from the nearest water source. Just as you need a trained plumber to oversee the septic tank, so you must have a plumber to do the same for your soakway. The length of your soakway will be decided by the approved plan you get to build it. Also, the depth it has to be will depend on the nature and absorption of the soil. Plastering your house is something that you can do yourself, but it will be a lot easier if you have an experienced plasterer to show you the way. It takes great skill to get a good, smooth finish. Now to mixing the plaster correctly. Using a 25-litre drum to measure, mix 1 part cement with 3 parts sand and 2 parts water. As you did when you mixed cement for your walls, use a large flatboard with a frame around it to mix. This contains the plaster, especially when you start adding water. First, mix your sand and cement thoroughly before adding any water. Once you do add water, add enough to make the mix easy to use, but not too wet. Before plastering a wall, you must wet the wall completely. Scoop some plaster onto your hawk and apply it directly to the wall, in a smooth upward sweep. Plaster small areas at a time, and remember that in order for the plaster to dry evenly, that a complete wall must be plastered in one operation. To level the plaster, pull a wooden straight edge over the plastered area with a sawing movement. The plaster should be 12mm thick. Once you've leveled the plaster, then wet it a little, and use a wooden float to smooth the surface. Plastering the inside faces of the window bays and doorways, or the reveals as they are called, is a more technical job than plastering the walls. To round off the corners, use a 90-degree angle tool. To level the plaster, pull a wooden straight edge over the plastered area with a sawing movement, and use a wooden float to smooth the surface. Hanging your doors, there are a few helpful hints you must remember. Most important, double check all your measurements before cutting. When measuring, measure the hinge positions from the frame head and transfer those measurements to the door. Be sure to do the same with the striker plate and lock. Also, always check that the slot for the lock is not chiseled out deeper than the depth of the lock. Before mounting the door, check that the hinges are fixed flush with the surface of the door edge. Lastly, check the size of the door in the door frame. If you do have to cut the door, then cut it on the lock side and at the bottom of the door. To paint the house, you'll need a few basics. First, to paint large areas like walls and ceilings, you will use a roller and tray. Paint is a really important part of building. Not only does it add to the looks of your house, but even more important, good paint applied properly will improve its durability and reduce the penetration of moisture through the walls. Check with your supplier about the right paint for your needs, because with some paints you don't even need to plaster your brickwork, you just paint straight onto it. And it is so important to choose a good quality paint. Better quality paints are more expensive, but in return they will last far longer than cheap paint, and you will know they perform like they are meant to. Before painting any surface, you should use a medium to fine sandpaper to sand it down. Before you start painting, consult your paint supplier and follow his advice. If you leave out a coat or miss steps, the shortcuts will show, and it won't be long before your house looks shabby and needs repainting. It is really worth getting this right, first time. Before painting your walls, remember not to paint before all the plaster is quite dry. Apply 2 coats of acrylic PVA to finish. Painting your ceiling, start by giving the ceiling a good clean. As with walls and ceilings, before painting metal door frames and windows, clean off all dirt, grease and so on. If the steel is not galvanized, then apply 1 coat of red primer before painting it. When the primer is dry, apply 1 coat of undercoat and let that dry. Finally, apply 1 coat of gloss enamel. Natural wood doors and windows need wood dressing. Before you apply it, sand the wood smooth, round the edges, and wipe the surface completely clean of wood dust. 2 coats of wood dressing will do the job. If you decide to paint your wood surfaces, the method is different to applying wood dressing. You will still need to sand the wood smooth, round the edges, and wipe the surface clean. Then apply 1 coat of pink wood primer. Once that's dry, follow up with 1 coat of universal undercoat. When that is dry, apply 2 coats of acrylic top coat in the color of your choice. Up on the roof, you can leave things as they are, or paint if you want to. Lastly, for metal roof sheets, clean the surface and allow it to dry. Then apply 1 coat of calcium plum bait primer. Finally, apply 2 coats of roof paint. The final finishes will be to close up the sides of your roof and to put in a good gutter system to drain water away from the roof. Starting with the wooden fascia boards that you will screw your gutters into. Then, onto the ends of the trusses, nail the 225 by 50 mm fascia board. To close off the eaves, you now fix soffit to the underside of the battens. You do so by nailing 10 mm quadrants through the soffit and into the battens. Barge boards are similar to fascia boards, only they run up the sides of the roof. Your gutters and downpipes are the drainage system for your roof. Spend time getting these exactly right and you will save yourself a lot of trouble. You will fix the gutter bracket to the fascia board at 1 meter intervals, using plugs recommended by the suppliers. Very important to remember is that to drain water to the downpipes, the gutter must slope down towards the downpipes. The flashing ensures no rain gets into the plaster or under the roof. And it's not just about the layer of flashing. You need to prepare this whole area with real care, starting with the building of the head wall above the level of your roof. The whole idea of the parapet wall, flashing, and the angle of your roof is drainage, moving water away from the parapet wall and off the roof as best as possible. The parapet wall is the first stage of this runoff, so it needs to be plastered at a slope, running downhill from the top of the parapet to the top back part of the parapet. The threshold at the bottom of your doors is an area that also needs real attention. Over this threshold area, you're going to spread a thin layer of mortar in which to set the threshold. The mortar is spread from the edge of the concrete slab over the top of the foundation wall and down into the groove. At the top edge of the groove, you will set a weather bar upright and into the mortar. Over this, you now spread the damp-proof course you laid down on top of the foundation wall before you began building the walls of the house. The damp-proof course now sets into this thin layer of mortar and runs over the weather bar and down into the groove in the foundation wall. When finishing the window sills under your steel-framed windows, you need to damp-proof this area as well. The procedure for a mortar-formed sill is much the same, except that instead of a pre-made tile or asbestos sill, you form a sill yourself, out of plaster, and slope it away from the window frame. Underneath it at the end, you will form a groove so that water running under the sill drops to the ground instead of running under the sill all the way to your wall. In glazing your windows, you'll need to keep track of what size glass goes where. Start by measuring each window. Mark the window frame with a number, and once you have measured the glass, write that number on the glass in a washable koki. Make a list of all the glass measurements and their numbers. If you have non-galvanized steel window frames, before glazing, you need to paint the frames with a rust-proof primer. To putty your frames, press a thin layer of softened putty into the glass recess. Carefully press the glass firmly and evenly into the putty, and make sure that you position it evenly in the recess. To finish, press a thick layer of putty into the remaining recess, and using your thumbs, press it firmly into place. Smooth the putty to a 30-degree slope, and lastly, clean away any excess.
After you've constructed your house, there may be the opportunity at a later stage for you to extend your house. This would have implications financially and practically, because the site would hopefully have been designed in such a way that it can be extended. But one would have to take cognizance of the fact that rates, costs would go up as a result. Your maintenance costs on the property may go up as a result of that. And one needs to take cognizance of this when one works out one's budget in the long term.
To help you build the best possible house, we have looked at everything you will need to know, how to do it, and all the possible problems you can face. Still, problems will come up which are possibly not covered in this DVD. If so, ask as many questions as you can to make sure that you sort the problem out properly. In building your home, if you are even a little unsure about what to do at any stage, ask someone with experience, someone you trust. The more questions you ask, the more you know, the better prepared you are to build a top quality home. And as we said at the beginning, building a house is an education. Finishing your house gives you two things, a home and knowledge. Two of the most valuable things you'll ever own.